Hello, everyone. I am Giulio Prisco. And for this episode of the Turing Church podcast, I'm in conversation with Rizwan Virk, the author of two books on the simulation hypothesis. The first is called The Simulation Hypothesis. An MIT computer scientist shows why AI, quantum physics, and Eastern mystics all agree we are in a video game. The second book is called The Simulated Multiverse. An MIT computer scientist explores parallel universes, the simulation hypothesis, quantum computing, and the Mandela effect. In the first book, Virk explains the simulation hypothesis, and I think his book is the best introduction around to the simulation hypothesis. And an especially interesting thing is that according to Virk, the simulation hypothesis bridges the gap between religion and science in ways that weren't possible before, and may just be the answer that provides a single framework, a coherent model that brings together science and religion. I entirely agree, and we're going to discuss that. In his second book, The Simulated Multiverse, Virk elaborates upon his previous book and introduces a very intriguing twist. It is not just one timeline that is simulated, but many. So we have a lot of things to discuss. I will start with the first thing that I wish to discuss right away. So Ben Goertzel noted that your first book was spreading the simulation hypothesis to a wider audience. He said that the simulation hypothesis is, and I'm quoting here, is mostly bullshit, but it does highlight some interesting issues. It's a worthwhile thought experiment, but in the end, it's most valuable as a pointer toward other deeper ideas, says Ben. The reality of our universe is almost surely way crazier than any story about simulation or creators, and almost surely way beyond our current imagination. That's what Ben said. And my question to you is, what do you think these deeper and crazier ideas might be?
Well, it's an interesting perspective. Ben, I think, is coming at it from the AI perspective. And as I understand it, he was involved in some well-known AI companies.
Yes, he is, but he's one of those people who is really involved in everything. And when he says something, I do tend to take him very seriously myself.
Yeah, well, I think, his point was that if you just think of a simple simulation hypothesis, which is having one creator with a bunch of simulated beings, that perhaps that's not crazy enough, right? And in some ways, that idea fits our current understanding of computer science, but doesn't bring in, at least in my opinion, other aspects of simulation theory, which is an emerging new field. And, in fact, I'm going to be teaching one of the first courses at a US university about simulation theory in the spring.
That's great. Can you say which one?
Yeah, it'll be at Arizona State University,
that's great.
Which is actually where I am now at the moment. So I'm actually working on a doctorate, looking at the metaverse and virtual reality. But I think that class is called Simulation Theory, Technology, Science, Philosophy, and Religion. And I do think that philosophy and religion have to be a part of this discussion. And if you look at how the simulation theory got popular recently, there was Nick Bostrom's famous paper in 2013, Are You Living in a Computer Simulation? And, in that version, he laid out the statistical argument, which many people have probably heard.
It was actually before that, I think. It was 2003, I believe.
Yeah, 2003 is when I think he published it. I think he wrote it even earlier than that. But that has gotten a lot of attention, and that's has the basic logic that led Elon Musk and to say that the chances that we are not in a simulation, or the chances that we are in base reality, is 1 in billions, right? There was a statistical argument saying there are many more simulated beings than there are biological beings. There are many more simulated worlds than there are physical worlds. There's only one physical world. Therefore, what are the odds you are in this versus that? But, so all of that is a key part of modern simulation theory. However, that assumes primarily an NPC version, as I like to call it, of the simulation hypothesis. Whereas I like to draw the distinction between the RPG version and the NPC version. So NPC stands for non-player characters inside video games, where everyone is an AI. And the RPG stands for role-playing game version, where just like in a video game, we have an avatar and we live outside of the game, and we are each, playing our avatars.
Right, but don't elaborate on this now, because we are coming to this point, which is an extremely important one later on.
Okay, sure, yeah. But so my general point about crazy ideas around simulation theory is, who is the simulator? What is the simulation? Is it that we're all running separate simulations and they're being merged together? Is that panpsychism, which is the universe? There's the self-simulation idea where the universe is simulating itself. And so there's a number of different versions of simulation theory out there. And those are, some of the crazier ideas about, I think the big interesting thing about simulation theory is it makes us reevaluate what is the nature of the universe, right? And so if we're looking at it from a pure materialist point of view with one single timeline, that's kind of the view that most scientists had before quantum mechanics really came to be in the last century, and most mainstream scientists still haven't quite internalized some of those weird problems of quantum mechanics in the real world. I think we still tend to have a very materialistic point of view. And I think, Ben, I don't remember specifically what he said in that article, but I think he's showing that simulation theory can point to lots of other crazy ideas about multiple creators, about zero creators, about how the universe, could be some type of an AI in and of itself, as opposed to the more simplistic model of one creator, and here's a bunch of simulators.
I think what he has in mind is how to say that yes, the simulation hypothesis might be correct, but we shouldn't think of someone who is simulating a reality. We should more think of some kind of system that simulates itself from inside. That's
right.
I'm not even sure that that is what he has in mind, but as far as I understand, he is he's writing a very complicated book, one of those things on the edge between science and philosophy and metaphysics and maybe religion and all that.
Yeah, well, that's an idea. That's one, aspect of simulation theory, and I can see where he would point to that. I mean, there's another gentleman named Clee Irwin. He wrote the self-simulation hypothesis paper, saying that the universe simulates itself in a strange loop. And so, this idea of what's outside the simulation, I think, is the big question there. Like, is it a simple simulator, or is it nothing? Is it just the universe is a simulation? I think the common thread amongst all these ideas and all these versions is that the universe is computing something, and that computation is a fundamental process in the universe. And I like to say, just like about a decade ago, a famous venture capitalist in Silicon Valley, Mark Andreessen, said software is eating the world. I like to say that computer science
is eating the universe.
Yeah, software is eating the universe, but also computer science is eating all the other sciences, right? Because in the end, we're discovering that they may be more about information and less about physical things, right. Which is why, pretty much at MIT, for the first time in, I don't know, almost many decades, if not 100 years, they've created a new school, right? They had the School of Engineering, School of Humanities. They actually created a new school called the School of Computation, which is less about computer science and more about how computer science is used in every other field that's out there. So
Right.
I think that's a common denominator that all of us agree on. Yeah.
It is, and in fact, I often think that at least some version of simulation hypothesis is evidently true, in the sense that obviously there is something which is simulating something. Now we have to study exactly what is simulated, what is simulating what, but it seems pretty sure that there is a what is simulating a what is being simulated. You just have to find out. So in the last couple of days, I have been, of course, reading, of course, your books again, but also that fantastic speech by Philip K. Dick that he gave in Metz, and it was called, I believe, if you don't like this world, you should see some of the others. And the novel by Jorge Luis Borges, El Jardín de los Senderos que se bifurcan, The Garden of Forking Paths. And Philip K. Dick and Jorge Luis Borges as really the heroes of your second book. Maybe you could say something about them and where their work connect to yours.
Yeah, absolutely. So, Philip K. Dick gave this speech in Metz, France. I think the title was, "If you think this world is bad, you should see some of the others." And his speech had a famous line in there that has been quoted by many people and even made it into a popular song by the group Maxtor. And in that line, he said, "We are living in a computer-programmed reality. And the only clue we have to it is when some variable is changed, some alteration in our reality occurs." And of course, the creators of the Matrix were inspired by Philip K. Dick. And in fact, I think he even used that term, the matrix of reality, at some point, either in that speech or in one of his other writings way back in the 70s. And so, because he had been an inspiration for this whole idea, I interviewed his wife, Tessa B. Dick, when I was writing my first book. And I just thought it would be a fun thing to do because I'm including a lot of science fiction references in my books, so that to make these concepts easier to understand. And she gave me more insights into what he was really thinking. And it was those insights that made me go back and read his whole speech. And it turns out that line that I just mentioned, the one that's famous and has been quoted, was not in the written version of the speech. He had ad-libbed it or added it onto the manuscript that he was actually reading in Metz, France. So maybe he thought of it while he was flying over there. But if you keep reading what he said beyond that, that's where it gets interesting. And eventually, after I wrote my first book, I realized, he wasn't so much talking about a single simulated world as he was talking about multiple paths in a simulation. And so, when he talks about a variable being changed and an alteration in reality occurs, he's talking about basically a computational process that runs more than once. And so he went on to say we would have the sense that we were reliving the same moments. We might have a feeling of deja vu, that we were saying the same words, hearing the same words again and again. And so there was this idea of repetition, and this idea of multiple timelines coming out of this. And so, this was quite interesting to me because I couldn't quite shake the thought after I wrote the first book that if we're in a simulation, there's no reason there should be only one run of a simulation. In fact, computer programs, that's how computer programs work. And so what he was really talking about was that somebody somewhere outside the simulation was changing these variables and rerunning the process to see what would happen. And, Tessa told me he came to believe that his most successful novel while he was alive which was The Man in the High Castle, which he wrote it all the way back in 1960. It was about an alternate timeline where Germany and Japan won World War II. And so he came to believe that actually happened, like that was an actual timeline, and that the people who are sitting outside of the timeline, they then tweaked the variables because they didn't like the result, and they reran that process, what we call, our history, a World War II. And now, of course, we live on a different timeline. We happen to be on a timeline where the Allied powers won World War II, and so that seems just like fiction. And so that was quite intriguing to me, both as a as a metaphor, but also as a core idea around how simulations work. And so in some ways, Philip K. Dick is like you said, the hero, one of the heroes of my new book, because I end up quoting him, and he even talks about how we would have to find people who might have memories of different alternate presents or different paths through the past. And so that, when I got in more into the quantum multiverse idea, I began to see a lot of correlations and connections between them. And then Borges, wrote a great story. And I have to admit, I hadn't read his stories until I read this one. And he's got quite a few, pretty well-known stories out there. But the Garden of Forking Paths was the one that I had seen referenced by physicists and other people. And the reason was, it talks about, this idea that there are many different paths. And, the story is of a gentleman who's in England, who's of Chinese descent, whose ancestor had written a book, and he had left this book unfinished, and he had created a maze in which all men would lose themselves. And so he was a famous ancestor, but nobody knew what that meant, because the book didn't seem to make any sense. In one chapter, a person would be killed, and then in the next chapter, the person would be there again. And then eventually it's revealed in the story that the maze and the book are the same thing, that they are both basically a description, not just of one reality, but in this story, everything that could happen happens, which means you create, if you think of a graph, right? And then I use various diagrams to describe this, but, a graph of ever expanding worlds. And that, there's a line from this other professor who discovered the meaning the meaning of that particular manuscript and the maze, that in this life we might meet as enemies, because one was on the side of the Germans in World War I is when it took place, and in another life we might meet as friends, and another we might not meet at all. And so I thought, those metaphors between science fiction and Borges' kind of fantastical stories were better ways to visualize this idea that we might be living in a very complicated simulated multiverse where many things have happened and will happen and even are happening, and we may just be on one of those branches of the timeline at the moment.
In fact, after the speech, I've started reading Philip K. Dick's exegesis, and I've written just the first page. I didn't understand a word. I'm going to, that's very, very, very deep. I'm going to try again tomorrow.
Well,
the
better thing to do with the exegesis is to first read Valis, which is a novel he writes about a fictional version of himself writing the exegesis. So it actually gives some context. It actually, in my opinion, it's easier to read that and then go to what he actually wrote, because in Valis he will say, and then I wrote this particular verse of the exegesis because of this had happened in the story. So that's so that would be.
Thanks. I'll keep that in mind. Now, we're talking about things that change, but this is a common idea, for example, in Christian theology, that eternity is beyond time. But how can things change beyond the time? That's the question everyone asks himself when reading, for example, Aquinas. And Philip K. Dick has this interesting concept of lateral or orthogonal time. Could you explain that?
Yeah, absolutely. So I first heard about this again from his wife, Tessa, and the basic idea was that we were inside linear time, and to us it looks as if time always moves in one direction, right? And so if you view that as either a two-dimensional line, or even a one-dimensional line, or a two-dimensional plane, she said orthogonal time, he came up with that because orthogonal means perpendicular to, right? And so in this case, it would be outside of that single dimension of time, but would look down on it from this higher dimension. And so, he used a metaphor in his speech where he basically compared each of the timelines as a suit in a closet, and they're right next to each other, and that the people who are not within any of those timelines are kind of looking at them, and they could take the suit off and put it on, and then they could experience that timeline, and then they could take it off, and then they could try on another one. And so, this is the idea that that there are potentially what he called programmers and counter programmers, right? Individuals that exist outside of time who are responsible for changing these variables. And that when they change the variable in the past, it creates a new timeline. And they're able to observe that from this this other area. And as you said, that ties very much to different theological ideas about the past and the future being as one. And, people who have had near-death experiences, for example, report, being outside of time and an experience that only took 5 minutes in our reality could have lasted days for them, and they reveal seeing the past and the future in a completely different way than we think about here. And so there are many different analogs for this. An interesting one that I came across in my research in the second book was in Islam. There's this concept of there's humans, angels, and then there's this other entity called jinns, right? Of course, we know them as the genies from Aladdin and the Arabian Nights. But what I discovered was that the jinn were not bound exactly the same way as we are in space and time, particularly in time. And that, one of the reasons why in Islam, I discovered a Sufi imam who told this story, and I actually hadn't heard it, even though I grew up, the Muslim tradition, that the jinn were allowed to go back and change physical objects in our physical world because they weren't anchored in time in the same way that we are. And that this is one of the reasons why they memorized the Quran word for word. Because I remember thinking, well, why do you need to memorize the Quran word for word? We have them written down now. And they said one of the reasons why was that the jinn were, in that case, were not allowed to change your memory, but they were allowed. Wow. They were allowed to change physical objects. And so that tied to this whole other aspect of different realities and memories and things like that.
Right. If you can, I find this absolutely fascinating. I don't really know much about Islamic philosophy. I'm just a student of Islam and of many other religions, but I would really like to know more about this. So if you have a reference, maybe just send it to me.
Sure. Yeah, I'll send you a reference. It's not a very well-known aspect, but there are some of the Sufis. They tend to have talked more about this than some of the more the more traditional mainstream Islamic scholars.
So these individuals that live beyond linear time, which would be those that in simulation hypothesis language are called the simulator. Is it what is it? Is it a what or a who? An impersonal thing or an individual? Or of course more individuals?
Yeah, well, that's the big question, right? That nobody nobody can agree on, but everyone has their own opinions on what that might be. Some people talk about it being, a kid in his mother's basement, right? It was just writing video games and programs. Some people talk about it as a single creator that has created this world and is looking in on it. I tend to be of the opinion that it's us, right? In that we exist outside the simulation and are observers of the simulation, and we are participating, in the game. Some people think it's aliens. Some people, in Bostrom's original paper, it was a future civilization that is creating what's called an ancestor simulation. So it would be like, for example, our game of Civilization video game. We might create the Roman Empire video game, or we might create virtual reality of the Roman Empire, which is one of the things, that meta and Facebook are pushing as educational uses of virtual reality in the future. And so that would be a simulation of your ancestors. And so that's what Bostrom thought it was. But many others have different ideas about what that would be. I tend to think it's us, and that we chose to play this game.
So this is very interesting for me. And if I'm understanding you right, you have this in the book, and now you explained it again. How can the simulator be us? What comes to my mind is that, we are here and now in linear time, but some part of ourselves, maybe some higher self, something like that, is also a part of whatever reality editing processes are taking place in the higher time. And so that since we are not only here, but also there, or perhaps I should say it the other way around, since we are not only there, but also here, then the me who is out there runs the simulation within which the me who is here is living. Is that what you have in mind?
Yeah, pretty much. That there's a part of us that is outside watching the process, and
Right.
that is what consciousness is. In the same way that when we play, if you and I are both playing a video game, right, you are watching it on your screen. And in fact, this is happening to us right now. Like,
Right.
this isn't a video game, or is it? But you and I are not really talking. I am watching my screen, right? And so there's a portion of me that's in the screen that's being redisplayed on your screen, and you are there, but you are also happen to be in the Zoom meeting. So we have this idea of a virtual presence that the internet has allowed us to think about more concretely. And so that's one way of thinking. Another way to think of it is, in computer science, you have this idea of context switching, right? And so when a process runs, if you think of a program as just a simple program that has a series of linear commands, what happens is the processor freezes that at this. It has something called a program counter, PC we call it, in assembly code, and it stops at that instruction, and then it saves all that information, and then it goes off and does something else. And then it comes back to that process in the same way that I might have Gmail running in my background while I have Zoom running in the foreground. And so when it resumes, it doesn't know necessarily how long it's been. It just resumes at the next instruction.
Right.
So the program just thinks it's now one step forward. If you think of time as a series of computational steps, it appears as if it was just 1 microsecond or whatever, but in fact it could have been an hour or a day if the computer process had been shut off. And so in the same way, we are both here and there. Our limited part of that process, it seems to us as if it's continuous, but it doesn't mean that it necessarily was. In fact, Philip K. Dick came up with his idea of this speech in Metz, France, of changing variables. And he wrote a story called The Adjustment Team, which was made into a movie called The Adjustment Bureau with Matt Damon and Emily Blunt, where there's this team and they would freeze everything and they would come in and they would literally change some things in a room and then they would resume, moving forward. And so, that idea was present in his thinking as well.
And this, I believe, is very much related to this idea that to this idea that consciousness is really one, and we are small subunits of some universal consciousness. And in fact, I think I read in Daniel Kolak's book, You and I, and also in something by Fred Hoyle, I believe that was October the 1st is too late, an example that is very much identical to the one you're giving now, that there is this something or someone that is computing something out of time, and this computation is continuously context switching between different sub processes, and I am one of these sub processes and you are another one. I think is very much like what you said.
Yeah, it's very much like that. And also, but you and I might also, it might also switch between sub processes, but it might also switch between different computations of the same process. So there might be multiple versions of me and multiple versions of you. It all depends on how the variables are loaded into the computer, into the CPU.
So let's come to this point that you started sketching before. The difference between NPC and RPG simulations, and why you like the RPG interpretation mode. So do I must say.
Yeah. Well, first of all, let me say that most academics, when they talk about simulation hypothesis, and including Nick Bostrom and others and scientists, they are talking about the NPC version primarily. However, when we talk about science fiction, we talk about The Matrix as a primary example of living in a virtual reality. That was primarily an RPG version because Neo and Morpheus, who was named after the Greek god of dreams, and Trinity all existed physically outside of the Matrix, and they had that wire into the back of their head, the brain-computer interface. And that allowed them to basically, be completely enmeshed within this reality. And so, the two are not mutually exclusive, because you can have a video game that has both player characters, like my avatar, and it'll have, the orcs that I'm fighting, or a bartender, or a bank teller, and there's a whole history in the video game industry of non-player characters. But now we're getting to the point where we can create virtual characters and avatars, or what I like to call AVIs, or AI avatars, that will live in the metaverse. And there's quite a few out there. There's one called Kuki.ai, Kuki, who I interviewed for an episode of my podcast a way back. And so, now that we are starting to think about what would intelligent AI look like, I think, we're very much focused on that idea. But the RPG one is perhaps more interesting. And so to use a science fiction example, there was another movie that came out in the same year as The Matrix in 1999 called The 13th Floor. And that was based on a German TV show called World on a Wire, which was based on a book by Daniel Galouye back in the 1960s called Simulacron 3. And in that, they created these simulated worlds so they could see what was going to happen, but they could also go in and basically inhabit one of the characters. And so they could play the character, if you will. Now, I like that version because I think it provides, and you talked about this early on, a gap, closing the gap between religion and science, right? And it does that by having a mechanism for this thing that we call the soul, right? Which is the piece of ourselves that might live not just in the here, but in the hereafter, right? In the afterlife. And many different types of metaphors are used for that. But I find that it gives us a way to think about also many anomalous phenomena that science can't explain. And it gives us a different model. It's kind of like in the back in the 1700s when people said rocks were falling from the sky. The scientists in Europe said, no, that's not possible. We know that's not possible because there are no rocks in the sky. And the problem wasn't the evidence. It wasn't that there weren't rocks in the sky. The problem was the model that we used of reality. And so I think the RPG version gives us a different way to think about and explain many of these things that cannot be explained in a purely materialistic model.
Yeah, I also like the RPG version, and I like to think of myself as something which is in both worlds. I have a part here, but also a part out there. But suppose I'm just an NPC, right? Now, is there anything that I could do or that they could do from outside to, how to say, promote me from NPC to real player? I remember, for example, that in Hans Moravec's first book, there was this thing where some creators living in a simulation managed to establish communication and a dialogue with the programmers out there. And at the end, with some work on both sides, they do get upgraded to the higher reality.
Well, you know, there's been a lot of science fiction about that idea that you could have a simulated person want to promote and exist outside. You know, in Star Trek, there was The Next Generation. There were episodes of the Holodeck, which had, you know, Professor Moriarty and Sherlock Holmes, where the professor was basically an NPC, but he discovered that he was inside this virtual reality and that there was something else out there. And so, you know, I think the communication is one aspect that seems like it should be possible, right? And it depends on the intel. This is where AI intersects clearly with simulation theory, because it's if those NPCs are truly conscious, I mean, if they're at the point where you can't distinguish whether they are conscious or not, going right back to the Turing test, right? You know, which I think most of your viewers will probably know about, and you know, which was originally called The Imitation Game by Alan Turing. But if you can't tell the difference, then have they reached a similar level of computational complexity as what we think of as consciousness? And you know, is it possible that we can only play characters that have reached a certain level of complexity, right? Whether it's neural complexity or others. And so, you know, we're getting into, you know, issues of uploading and downloading of consciousness here, and right, because there's this idea of a digital afterlife, which many, you know, many technologists such as Ray Kurzweil and others seem to subscribe to, that if we can map out all of the neurons in the brain, what's called the connectome, we can make a snapshot of that, and now you have a copy of that person, and then we can upload you into silicon or a computer, and now you can live forever in this digital afterlife. And there has been some great science fiction like this, the TV show Upload, and some episodes of Black Mirror that really riff on this idea. And so in Upload, for example, he goes in, his body has died, and he's basically just in the computer generated reality, which is like a resort town that has all kinds of glitches. But then that's sort of an upload, and then you know, they're looking for a way to get him back into physical reality, and so they grow a copy of his body and then they're able to upload him back into that. And so, you know, if we are a type of information, and if we can grow biological beings, then we would be able to do that within our simulations. So who's to say the guys who are simulating us couldn't do the exact same thing? Where, you know, so on the one hand, in the RPG version, all you have to do is take off the virtual reality headset in your back. But in this case, the NPCs might want to, you know, they or we or whoever's outside may want to pull someone out of the simulation or save them to run in another simulation. And, you know, it may be multiple simulations, and that gets into another whole host of issues. Yeah.
In fact, this possibility to promote NPCs to the next level, in fact, I think is the one that looks more like traditional Christian theology, where we don't really have an immortal soul. I mean, the concept of resurrection in traditional Christianity is not immortality of the soul. It is the resurrection of the soul and some form of the body by explicit intervention of God. We would not have spontaneously an afterlife. It's all the work of God. So that is what I found is very similar to the concept that someone from out there can decide to upgrade an NPC to the status of real player, but So, let's come to the very core point of your second book, The Simulated Multiverse. And you have a very good explanation of why the simulator runs many universes instead of just one. Could you give a short version of the explanation?
Yeah, sure. So, the kind of position that I came to after looking into this was that there's a reason why when you run a simulation, you don't just run it once, right? And this is true of simulations of the weather, simulations of traffic forecasts, right? Simulations of pandemic and how the pandemic will spread. So, if you think about it, why do we run simulations and why do we play video games? Let's take those as two separate concepts. And the reason we run simulations is we want to see what will happen if the variables are set to X, Y, Z, right? The simplest simulation in computer science is like a population simulation. You don't even need a graphical world. You just say, here's the population on year one, and then this is how it changes in year two. And you give it a variable, and and then you have to run the simulation. And each year you just come up with a population of fruit flies, right? Using the birth rate and the death rate. A very simple simulation, right? But the only reason that's useful is if you can change those variables and you can say, well, if the birth rate was higher, or if there was some external thing causing more deaths, what would happen to the population? Well, you take that to an extreme in today's simulations. We run many scenarios, right? There's something called a Monte Carlo simulation, where you run lots of random variables. And I've seen this for traffic inside a bank. Where do people stand, right? And you see the dots, but you do it to get the most likely outcome. But then the other reason you do it is to try to get a more optimal outcome, right? And so, for example, you might say, if with this intervention, what will happen to the monetary supply? What will happen to prices? What will happen to unemployment? And so all of these are variables that we are looking to optimize. And the only way to optimize it is through a search space of searching through. And within chaos theory, there's this idea of a small change in initial conditions will result in a very big change down the road. And so this is the source of the famous butterfly effect, where the butterfly flaps its wings in Hong Kong and the stock market crashes in London. Okay, that those seem to not be related, but there's a whole series of things that happen in between the two that cause a small change here to result in a big change there. And this ties to an idea by a physicist turned computer scientist, Stephen Wolfram, who is well known for his work on cellular automata, as well as having created the Mathematica software. And he came up with this term called computationally irreducible. And he said that the reason you have to run the simulation is because you can't just take a shortcut to figure out what's going to happen. And many processes, including like the three-body problem and other problems like that, the only way to figure out what will happen at step 1,000,000 is to see what will happen at step 999, 999, and what will happen at the step before that. And so we run the simulations by changing variables to see what will happen to get either the most likely outcome or the most optimal outcome. And it turns out that's maps to what Philip K. Dick was saying. He was saying that they would run a timeline by making a change and see what happens, and then they would change it, and they perhaps didn't like the timeline where the Axis powers won the war, and so they went back and changed it. Now, it's possible in his thinking that we are still in one of those test timelines, and they may change it yet again, right? I mean, his wife gave me the example that he thought the simulators had told him, whether you believe this or not, he thought he got in communication with these entities that were running the simulation. What's that?
The thing that he called Valis.
Yeah, Valis was a very large active living intelligent system, I think is what it stands for. But so he came to give it kind of this name. But in this particular story, she said he seemed to be actually talking with someone, and they told him that they had changed the assassination of JFK, which I guess was, on everybody's mind back in the 60s and 70s, and that they had rewound his assassination in Dallas, but then he got assassinated in another city, in Orlando, and then they changed that and he got assassinated somewhere else, or that when he didn't get assassinated, the timeline led to a nuclear war or some other bad outcome, right? And so this gets into this idea of what is the best outcome in a simulation, right? And we can talk about that if you want now or later.
Right. Yeah. In fact, you say that the simulation or the simulator is looking for better outcomes, just like our evolutionary computing simulation explore networks of alternative timelines to find good ones. But here I wonder how we could define what is a good timeline, and how can the simulator evaluate the goodness or a specific timeline? What criteria could they have in mind?
Right. And so, we just referenced, evolutionary algorithms, and the way that they work is they will typically change, based on the idea of evolution. You'll have mutations and combinations, and they will basically do these a certain number of times, and they'll have what's called a fitness function.
Right.
And the fitness function is a simple numerical function, typically, that says this is better than that. Now, of course, in real life, that is more complicated, because what you can't just say, hey, the best outcome for employment, right, is necessarily the best outcome for everybody. And so this gets into issues of communism versus capitalism, different economic systems, and how you evaluate the fitness. And so I think this gets back to our earlier question of, is there one simulator? Are there multiple simulators? Are we part of those beings who are simulating it? And so that's where I think it gets a little more complicated. So I think in the simple picture, you have different timelines, and there is some additive, aggregate fitness function. Now, we get back to this other aspect that I mentioned earlier, is why do we play video games? Right. So why do we simulate? I talked about, but why do we play video games? And one of the reasons is we want to have certain experiences, right? I might play a space video game so that I can fly a spaceship, because today, at least in our physical world, that's not something I can do. I might play a fantasy video game so that I can, fly on a dragon. And so I may have different criteria. And I actually came to believe that we all have different storylines in this reality that obviously are constrained generally by the things that we're allowed to do here. And that each of us, has these different storylines and things we might want to accomplish in this life, kind of like a plan or an outline of a novel, but we are free to choose and try different things. So each of us has our own fitness function, in a way, if you will, which includes it's just not a numerical value. It's not like how many years that I live, but rather what experiences am I here to have? And so if you think of billions of people, each with their own fitness function, and then you have a larger fitness function, right, that looks at everything, you can add it up, and that gives you a case for which timelines are perhaps the most interesting to the group of simulators that are out there. So that's one way that I like to think about it.
Right, and of course, I guess just because of the computational irreducibility that you mentioned, one really has to run all these timelines. One cannot know in advance what the evolution will be. And I guess this is why in your framework, whatever is doing the simulation has to compute many different timelines.
Yes, exactly. And, Wolfram came up with that idea based upon cellular automata, which are very deterministic rules, right? So even with deterministic rules, you had to go. Now, if you add free will and quantum, physicists tend to think of it as the same as randomness. That's a whole nother discussion and argument. But if you add free will to it, you now have sort of indeterminate rules, which means you really don't know what's going to happen because people might make different choices at different times. And so that's part of the reason why you have to run these different timelines to see what might happen.
Right. In fact, when we think that the simulator is constantly creating multiple timelines, branching and merging and eliminating timelines, the question would be, what happens to conscious observers when two timelines are merged? I mean, do they remember the memories that correspond to the first timeline, to the new one, or what?
Well, that's part of the puzzle that I was trying to delve into in my second book, the simulated multiverse. And I came across a friend of mine from MIT who was working for Google, and I happened to be living near Google's headquarters. He came and we had coffee, and he said, "Hey, have you looked at this thing called the Mandela effect?" And I had heard of it, but not from any of my engineering or scientist friends, because that wasn't a topic that was covered there. It tended to be covered with people who are looking at more fringe events like UFOs and aliens and things like that. And the Mandela effect is a term that was coined by a blogger about a decade ago when she discovered that a subset of people remembered Nelson Mandela dying in prison in the 1980s. And of course, in our timeline, we know he didn't do that. He got out of prison, he became president of South Africa, and he won the Nobel Peace Prize, and he died, I think it was in 2013, right? And yet many people swore they not only remembered him dying, they remembered watching his funeral, they remembered his wife, Winnie, taking over leadership of the African National Congress. And so, I had kind of dismissed this as just faulty memory. But it turns out there's a whole bunch of these Mandela effects that are out there where people remember, whether it's different lines in movies that perhaps are a little bit easier to say, hey, that was just a mismemory. But there were also many different events that people remembered. For example, at Tiananmen Square, right, where the guy was standing in front of the tank, who many people call Tank Boy online. Did he die or did he live? And so a certain group of people remembered him having died and the tank running over him and it being really bloody. And of course, if you go and look it up, at least in our timeline, that didn't happen. And so, psychologists would take one view of it. And I said, well, what if these people are actually remembering something that might have actually happened? And going back all the way to 1977, Philip K. Dick said, all we would have to do is find a subset of people who, like him, remembered an actual different timeline. Right. And that tied to this religious thing that I found in the Islamic traditions about how jinn are allowed to change objects and events, but they're not allowed to necessarily change memories of everybody. And so as we think of the traditional way of looking at it is that these worlds are just branching out, but sometimes they merge back together. And so I think it's possible as a player of the video game that if you were able to participate in another version and now you are participating in this version, that you could actually remember a different set of events than everybody else remembers. And it's up to the computational process to try to reconcile, all of these different memories, but also to reconcile where we are today. And so, now you get into these diagrams of timelines merging, A and B merging together, which is the majority, which is the minority. But because there are so many of these Mandela effects, it's not just two timelines, it's many different branches off of these variables. Each variable is like a binary, if you will, choice. And so that results in an exponential, potentially, number of
right. There are a lot of interesting things to explore in this direction. But let's think of something simple first. Now, suppose the simulator decides to eliminate this timeline right now. Okay? So what happens to us? What happens to you and what happens to me? Do we end up somewhere? Does our consciousness go to another timeline?
Yeah, so I'm of the belief that the timelines, what it means for the timeline to stop is basically to save the results, right, if you will.
Or to merge within another
and then
one.
to merge with another timeline. And so if we are part of this timeline, we then become part of this other timeline, which might run up to a similar point in time. And then moving forward, we might not have that timeline anymore because the simulators have decided that that's a non-optimal timeline for whatever reason, right? So originally they ran both in parallel. I mean, you can think of these as happening in parallel, or you can think of them as happening serially, right? And the idea of quantum computing, and I quote an Oxford physicist named David Deutsch, who has written about this a lot. Quantum computers are theoretically able to solve problems that grow exponentially. So what we call intractable problems in software. And intractable problems are ones that, probably a good example is the king and the chessboard in India, right? Where the king likes to play chess, but nobody wants to play him anymore. But he asked this wise man, please play chess with me. I'll give you whatever you want if you win. And the wise man says, okay, why don't you, if I win, you give me one grain of rice on the first square of the chessboard, 2 grains of rice on the second square, 4 grains of rice on the third square, and all the way to the 64th. And the king thinks, okay, that's no big deal, just a bit of rice, I'll do it. Well, the guy wins, and it turns out by the time you get to the to the 64th square, 2 to the 64, it ends up being more grains of rice than you can store in all of India. So that's an example of an intractable problem or a problem that grows exponentially. And so Deutsch said, the reason he thinks quantum computers can solve this problem is that they can explore all of these paths simultaneously and then basically hone in on the one that has the answer. So what happens to the other ones? Well, they were computed and they just kind of stopped computing at that point. And so if we think of, where we are in the game that we're playing, we now start paying attention to just this particular timeline. So I think that in my opinion is what may be going on, where these timelines are abandoned. But they're also stored as information. So if they ever needed to, they could bring them back. So that's a whole nother twist, though, that we won't get into, right?
In fact, now that you mentioned quantum computing, I do like the fact that in your simulated multiverse, unwanted timelines are eliminated and only good timelines are continued, because this seems much more cost effective than Hugh Everett's standard quantum multiverse of all possible worlds. And this is a thin multiverse. You have some worlds, but not some other worlds. And are you perhaps aware of quantum physics research that works in this direction? For example, Robin Hanson had this idea of mangled worlds, multiverse, where what happens is that low probability worlds merge into high probability ones, not necessarily by some kind of intervention, perhaps just by way of the laws of physics. Have you encountered some quantum physics theories, perhaps even mathematical, that come to the same conclusion?
Well, so, I have heard of Robin Hanson's Mangled Worlds, and I looked into it briefly, but, I can't say I've read extensively on it, but I think, he talks about measurement and how that doesn't necessarily, larger worlds and smaller worlds, right? Larger worlds are before you do the measurement and the smaller worlds come after. And what he's trying to do is link this idea of probability, right? So, was it Max Born, I think, who basically said that the square of the amplitude of the wave function is actually the probability of certain events happening within quantum mechanics. And so this is something that, has been, it was one of the reasons for the multiverse theory in the first place, because nobody knew how we went from a probability wave or a wave of possible events or positions to a single position that is observed or a single measurement that happens. And in the Copenhagen interpretation, it was called the collapse of the probability wave. And so, it seems that when the part of the reason why Everett came up with the multiverse theory was there was no mathematical way to get from this to that. And so he came up with a mathematical way of decoherence, where you would basically take out the different probabilities as separate waves. And the implication was that each of these would be a separate world in and of itself. Now, the one criticism of many worlds theory has been that it's not economical, right? And this is the difference between physicists and computer scientists, right? Computer scientists are always looking to optimize, particularly optimized information, but also optimize processing time through different algorithms, et cetera, because we always have limited computing resources. Whereas physicists are happy to say, and it goes on to infinity, right? Without really explaining, what that might mean. And so I was intrigued with, Hansen's idea that certain probabilities are so low that they just disappear, or they get merged into, because there's no reason to compute that. Now, I came at it more from a digital perspective, right? In the digital world, if you think of quantum computing, if you think of a series of bits, like let's say 4 bits, right? That automatically represents 2 to the 4th power, in this case, just 16, but different possible values of those bits. And so if we think of the entire universe, let's say there's 2 to the 80th power is one estimate of particles. No one knows the exact number, but let's suppose that was the number. Then if those are and we have a certain number of bits to represent that 2 to the 80, so it's 2 to the 80 times n. But really that number, those bits, and all the values of those bits basically represent all the possible states of the universe. Right? And this is what I call the multiverse graph. And so basically, anytime you have a set of bits, you can think of it as a multiverse graph. And so it's a matter of what computation you are doing that in how you want to explore this multiverse path. Another idea I came across that was quite interesting was Schrodinger actually referenced this idea of multiple possible histories and multiple possible paths. And that was one I hadn't heard before. And it predated, Everett was in the late 50s, I think 1960 or 59 was when he published his thesis, somewhere around then. But Schrodinger talked about this in the 40s. And this idea that there might actually be not just multiple futures, which I think we can kind of it's pretty easy to visualize. I might do this or I might do that, right? Those are two different futures. But it's hard for us to visualize multiple possible paths. And so, he came up with this idea that there are different simultaneous histories, and you are choosing one of them when an observation is made. So not only are you looking at the cat, Schrodinger's cat is both alive and dead, but each of those alive and dead have a whole history of what the cat was doing before it got in the box. And so when you make the observation, you are choosing one of those. And John Wheeler came up with the delayed choice experiment, which I think is the best way to explain this idea. But it also gets into this idea that there may be multiple paths, and we are choosing one of them. Right. And by choosing one of them, we are essentially discarding potentially the rest of it. So that's another sort of way to think of it. Those are some things that I've come across that touch on similar ideas.
Interesting. In fact, if you read Schrödinger, you find out that he anticipated a hell of a lot of things that people restarted discussing decades later without attributing them to him, and perhaps without even knowing that he had anticipated them. But in fact, of all these things of multiple pasts, how to choose whether we are RPG or MPC, branching future, branching past and all that, I was thinking in the last couple of days, I was analyzing my own memories. Maybe I wanted to come out with some personal experience of the Mandela effect or something like that. But I focused on one memory, which is that, once, very long ago, I did something which was very much not like me. Or to say it better, I did not do something which would have been extremely like me. Something that, according to the state of the universe at that moment, it was virtually certain that I would do that thing, but I didn't on 2 separate occasions. Now, I cannot find any reason why I didn't do that thing. And so the thought came to my mind that, this idea that in the RPG picture, we are kind of the programmers ourselves, so we can choose. So perhaps, the result of doing that thing, perhaps it would have been so bad that I have edited it out of reality or something like that. How plausible this kind of weird ideas is to you?
Well, that reminds me of Philip K. Dick novel as well.
Of
It
course,
almost
of
sounds
course.
like science fiction, right? Where you replace the memories of a
Right.
specific time, and it's been used a lot within science fiction. But I think it's very possible that we have chosen to forget certain things. This gets into very metaphysical types of issues around what is memory.
Not really forget. It's not what I have in mind. Not like we have chosen to eliminate certain things from the history of the universe, not just from our memories. We have chosen that certain things did not happen. And the result is that those things do not happen.
Well, that's interesting. So it's like choosing the past, right? In a way.
Yes.
like you're actually saying, okay, this particular branch of the past,
that
I
was
didn't
bad,
like it.
so let's eliminate it and let's replace
eliminate
it with
and go this way. Yeah, well, that's very interesting. So, when I draw this graph, what I call the multiverse graph, I talk about how there are many paths, and you can get to the same point, the present, by going through different paths. And so, in this case, you're kind of describing a path modification, if you will, right? If we think of history as in a computational model, right, as a series of line segments between the nodes, right? And the nodes are the states of the universe. Then effectively what you're saying is I'd like to replace a part of that path with another part, right, because we don't like that path. And so, this is actually, within like graph theory, they talk about path optimization. And, I can't say I'm super familiar with all of those things nowadays, but back when I was at MIT, I spent a little bit of time looking at, this question of does P equal NP, and this idea of being able to find the optimal path through a particular set of nodes. And so I think it's very possible in a computational model that you could do that, right? You could actually say, okay, this piece was unoptimal. So in the same way that I'm saying we drop a whole timeline, perhaps we don't drop a whole timeline. That might happen at an aggregate level, or at a personal level. You might say we're just going to drop one segment of the timeline, because the timeline now is a path rather than just a line, right? It's a path between different places. And so I think that could be possible in this case. If something we wanted to continue on, it's kind of like the merging idea, but you have to replace it with something else, right? So you're replacing it, you're merging or replacing a single segment of the entire history, not the entire history.
But as a matter of fact, now that I'm thinking of it, if eliminating one segment that we do not want, isn't that equivalent to merging a timeline into another in such a way as to make the first timeline disappear? The thing is that this was a bad timeline. Now, I don't want this, I want this because it's a good one. So let's bring them together and let's make the first one disappear, so that all observers in the first one at some point find themselves in a universe that is identical to the past of this one. I'm thinking about.
Yeah. No, that's kind of what I'm thinking as well, is that when I say replace a line segment, if we think of history as a series of line segments through this graph, and you can basically say, I'd like to replace this with one or more, but because of the time time, linear time within the path. It seems like time is linear within the path. You have to replace it with a line segment that is of the same length, right? So you couldn't go off for 100 years and do something else in that and still get be able to kind of correlate and get everything reconciled. But you could easily do it. So, I use this example. If you go A, B, C, D, and then you have A, E, F, D, right? You may have, if you do these nodes, you can still get to D. You can start at A and get to D by going in different paths, right? So if you, let's say B is this way and C is this way, and then they both go to D, right? So you can get to D using one of the two paths. You can go from A to B to D or A to C to D, right? And now if you extend this much longer, now you can think about, there are lots of ways to get to, which gets to this idea of potentially even multiple observers having different memories of different things, as well as you said, where the universe just replaced one completely as well. So it gets very complicated, I think.
Fascinating. I could be discussing these things forever. I think I have already taken a lot of your time, and so let's wrap this with another couple of things. All these things look, the consequences, all these things invade the territory of religion very much. And in fact, in your second book, you have noted that the Mormon Transhumanist Association has formulated a version of the simulation hypothesis, which is very much compatible with their own theology. Is an interpretation thereof. Now, do you think that it could happen that all the ideas that we are discussing are at some moment, appropriated by the traditional religions of the world and used to reformulate their own tradition in this more modern language?
I think this is likely to happen for the reason that religions use the metaphors that are available to them at the time, right? And so in Christianity and Judaism, there's this idea of the book of life, right, which people's names are recorded, or in Islam there's the scroll of deeds, which is a scroll of every single thing that you've done in your life, right? And so these angels are writing down every little thing. Now that's a metaphor, right? That doesn't really mean there's a physical book with angels that are using a fountain pen to write down everything. But if we think of it in today's terminology, we record our video game interactions, 3D interactions, and then we replay them on YouTube and we stream them on Twitch. And so recording everything is technology that wasn't available back then. So no one would have understood it if they would have used that metaphor. So today, like for example, when I talk with people who've had near-death experiences, they talk about a life review, right, where they have a visual holographic 3D representation and they watch everything that happened in their life. And so, to me, that suggests a recording because that's the metaphor and the technology that we understand today. And it suggests an element of free will. And so I think that spiritual reformers, now I'm not saying that necessarily the Catholic Church will start talking about simulation, but there are always reformers and modernists within religions who try to bring the religions up to date. So for example, I'm writing a book now about a Hindu guru named Yogananda, who came from India to the US back in 1920, and he wrote a very famous book called Autobiography of a Yogi. And at that point, he started to use metaphors which made sense to an American audience, and he used the metaphor of a movie projector, right? We were just becoming familiar with a film projector, and when looking at the suffering in the world, particularly around World War I, which had a level of death and devastation that hadn't been seen before, since it really was the first large-scale, massive, mechanized warfare. And he was looking at this, and trying to figure out, why would God allow this? And he was given a very clear message. Well, think of it as because he was literally watching these film reels. The news used to be shown in the movie theater. They would have those news reels before the film. And so he was given a very strong message that think of it like a movie projector, where yes, the people in the movie die, but the actors are not necessarily hurt from that process, but they chose to be part of it and to go through the suffering of that specific part. And so that was a new metaphor. And it was bringing it up today. So I believe if Yogananda were alive today, he would say, we live in an interactive movie where you can make your choices and what does that sound like? It sounds like a video game. So I think for that reason, and also the reason that today, many young people spend more time in the virtual world and playing video games than they do watching TV or linear movies. I just saw a graph that showed by generation how many played video games versus watched linear shows, and it was went straight down, like in terms of percentage, from the older generation to the younger generation. And so I've had many parents tell me they bought my book to read it, and their kids grabbed it, their teenagers grabbed it because they wanted to know, are we living in a video game? So I think the terminology is one that is better to explain to people, and it becomes a way for people to understand. There was a philosopher, a British philosopher, I'm forgetting his name now, but when he read Bostrom's paper back in 2003, he said, this is probably the most interesting thing in theology that's happened in the last 2,000 years, which is a new way to formulate this idea of a deity and of eternal life outside of, and there was a scholar of religion that I've gotten to know named Diana Pasulka. She's at University of North Carolina. She wrote a book called American Cosmic, but her area of research was Catholicism and purgatory. And she has a lot of interesting stories about the history of purgatory and how it was an actual place. But, she and I talked about simulation and technology. And she talks about how technology and religion are very intertwined in ways we may not even understand or realize, and that new religions evolve. And so, simulation theory, as I mentioned earlier, has been called religion for atheists, right? Yes. But it provides a framework for it. So I do think there will be new formulations of existing religions that embrace these ideas. Obviously the ultra conservative folks in every religion, tend not to like those types of reforms, but I think it's inevitable within different religions today.
I really hope so. That will kind of revitalize religions. But, and this brings me to the last question that I have in mind. The thing is that, if you think of what the real appeal of religion to so many people is, I think it's evident that we want religion because it offers hope in life after death. So what would be the concept of an afterlife that your framework can propose?
I think, it offers this idea of life after death that also offers some level of meaning, for what happens here, I think, in this world. And so I think in using simulation theory, we can start to think about what happens here in different ways. And so, in my personal opinion, it means that because we go through many challenges in life, right? Whether it's physical health problems, relationship problems, financial problems. But if we think of it as an experience that we have chosen to have inside this game, then perhaps it lets us deal with it much better. Because what happens in a video game if you don't succeed the first time? Well, you try again. They're like quests or challenges that you have set up for yourself, and which is why we often might end up having different variations of the same problem in our lives with different people being presented to us. But within this overall idea, one, it can give us comfort during this life, but two, then death really is simply the ending of this storyline. So I believe we have storylines that we have chosen for ourselves. And these storylines might involve different things, and we might make choices to not go along certain paths, like I in the garden of forking paths, right? Like when I was about a decade ago, I was walking at Stanford University, and I saw a vision of myself teaching and being a professor. And in this life, I had not chosen that as my career path. I was out in the business world and starting video game companies, but I saw it very clearly that that could have been a path, and that would have been what my life might have looked like had I gone down that. But now, in this case, I'm actually in academia now, later in life. So I'm actually taking that line segment, if you will, and seeing what would happen if I took that storyline. And so, I think, we take off the virtual reality headset, we unhook the wire into our brains, and then we can look back at what we did, and we can look back at it in a more objective way, to see the things that we might have accomplished and things that we wish we had done differently. But we can, we have some comfort in knowing that, we still exist outside of the simulation, and we had a hand in playing this game. So to me, that is a very comforting thought, and I think it is very similar to what traditional religions have been saying, whether it's the Western religions with an afterlife or the Eastern religions where you go back and you play again with reincarnation, for example. So I think it fits very well of the idea that we exist, the RPG version, that we exist outside of our characters, and that this is not all there is.
Yes, and I guess also in the NPC version, like we were discussing before, we can always take comfort in thinking that if we are really an NPC, then the possibility exists that the players could decide to promote us to the next level.
That's right. Yeah.
I guess.
Yeah, that's right. In that model, you could be promoted to the next level and become a conscious player, and then allowed to observe and participate in other games.
So we have all the good things of religion within a nice and intellectually fun and challenging scientific framework, which is, I think, something good. But I really want to thank you for your time. This has been a most illuminating conversation, and I'm going to think a lot about this, and I look forward to seeing you again soon. And thank you very much for joining me.
Absolutely. Thanks very much for chatting with me. This has been a lot of fun, and I look forward to our next chat as well.